Now I'm writing concept number 1, which is very important, saves a lot of time, right? Concept number 1. Okay, even before writing the concept, let us just do a very quick example. Suppose there is a number 60, right? Suppose I have a number n, which is, or let's take a more weird number, 70, right? 70. Okay. Suppose I increase 70 by 30%, right? I increase 70 by 30%. What does this mean? This means that to 70, I am adding 30% of 70. Correct? Correct? To 70, I'm adding 30% of 70. So basically 70 plus 21, which is 91. Right? This is what we mean when we increment or decrement any number by certain percentage. So let's take another example. If I were to, decrement 90 by 20%, what am I doing? I am subtracting 20% of 90 from 90, right? I am subtracting 20% of 90 from 90, which becomes 72. Now, the idea is that rather than taking the my intent is to find the final number, right? My intent is to find the final number. If a number is decremented by 20%, what I am right now doing is I am figuring out the 20% of 90 and then I am subtracting that from 90, right? This is not what I want. I mean, this calculation is sort of irrelevant to me. Why do I need to calculate the 20% of 90? I can do it in a more direct manner, wherein comes our concept 1, right? Wherein comes our concept 1. Concept 1 says that if n is, let's say, incremented, right? And for decrement, you can obviously replace the plus sign with minus. If n is incremented by x%, right? Then the new number is 100 plus x% of n, right? Here I'm not considering the intermediate state, right? I can directly write this. What does this mean? Look at this, okay? I'm rubbing this slightly because this is a more traditional method and we don't need this. So let me just quickly rub this off. Okay. Now, the number is 70. If I want to increment it by 30%, what did we say? We said that if the number is incremented by x%, it becomes 100 plus x% of itself. So if the number is incremented by 30%, it will become 130% of itself. And here is your answer directly, 91. Right? In the other case, we said that 90 is decremented by 20%. So what does 90 become? It becomes 100 minus 20%, which is 80% of 90, right? Which is simply 80 by 100 into 90, which is nothing but 72. Now, if you do some part of the calculation in your head, you probably are just trying to multiply 13 with 7, right? So that's how it can be made faster. You're just trying to multiply 13 with 7. Here, you know that 80% of 90. If you practice more and more, you will realize that 80% is nothing but 4 by 5, right? So I'm just trying to find 4/5 of 90. 4/5 of 90 looks very easy to solve, right? Simple. 4/5 of 90 is 72. So that's how you can improve upon this technique. But the idea is this, right? And why does this work? This works because I'm writing a new statement. This works because every number n is 100% of itself, right? Every number n is 100% of itself. So if you take 70 and you increment it by 30%, 70 itself was 100% of itself, right? And if you're incrementing it by 30%, so the new number should become 130% of itself. Similarly, 90 was originally 100% of itself, right? Every number is 100% of itself. 90 was also 100% of itself. You decremented it by 20%, so it became 80% of itself, right? So that's why this concept, gets used quite a lot, and this is why this concept works. Okay, so I hope it is clear to you. See, I understand some of you might not be having very good calculations right now. That is perfectly fine. The idea is you need to know that it is 80% of 90. Figuring out that 80% is 4 by 5, that will come with time, right? It's not very difficult also, but usually it will come with time. But the moment you understand that it is 80% of 90 and 80% is 80 by 100, your work is done, right? And you can clearly see that we are here trying to avoid the intermediate step of reducing the number by 20%, right? So we're not calculating 20% of the number and then subtracting. Why do I want to do two operations when my work can be done in one operation? Even if there is like a hard number that comes up like 73, so you're saying that the number is 73 and you increment it by 30%, right? So if your number is 73, right, and if you increment it by 30%, the only problem, the concept still remains the same, right? The new number will be 130 by 100 into 73, right? So 130 by 100, rather than writing 130 by 100, you can usually write 13 by 10. 13 by 10 into 73, right? The concept still remains the same. It's just that you have to be fast with your calculations. What is 73 into 13, right? So the way I usually do it is I do 73 into 10 in my head, which is just a zero addition. And I usually remember these small numbers like 73 into 3 is 219. I know that, right? So if I just add them up, this is 94.9, right? I mean, I have divided by 10 also. Fine. If you want to increment it by 87%, that's also fine. Usually, I'll tell you. So if there is a question that asks you to increment this by 87%, right? If you want to calculate the precise answer, then the precise answer is this, right? The precise answer is this. You have to multiply 73 by 187. There is nothing that, you can do to avoid this. But if you want an approximate answer, and if you are fairly good with percentages, you should understand that 87% is approximately closer or very close to 87.5%, right? And I know 87.5% as a fraction is 7 by 8. So what I will do is I'll simply do 73 into 15 by 8, right? And that sounds simpler. That sounds simpler, right? That sounds simpler. So 730 plus 365 by 8, which is 1095 by 8, right? 1095 by 8, 1040 I know by 8 is 130, so plus 45 by 8, right? So 135.625 should be your answer, right? If you want an approximate answer. So something around 135 is your answer. Fraction to percentage conversion is nothing difficult or nothing different, right? If you know a fraction, you just multiply it by 100, you get the percentage, right? We did, right? 1 by 2 multiplied by 100 gives you the percentage, 50%, right? So nothing different. The only thing is, sometimes when you find out things like 73, 87 examples that you took, which could be quite cumbersome to solve, then it ultimately boils down to your calculation skills, right? Calculators can be used, but I don't know if you have taken the CAT previously or not, but the idea is that you cannot use a keyboard there. So you have to use a mouse, and pressing the mouse, 7 times, like if it's 3-digit multiplications, so 3 digits 3 times, 3 digits 3 times, and then a multiplication, you'll think that, okay, I'll do it manually. I don't need the calculator. And that's a waste of time. Yes, it is very useful in profit and loss. Why? Because sometimes, you're given that somebody makes a profit of 25% and then he gets and sells it at 500. What is the cost price? So right? If he makes a profit of 25% over cost price, his selling price is 125% of the cost price, which is already given to you. It's applicable not just in this, but also in a lot of places. Name which exact part are you talking about? The increment part, you mean incrementing 73 by 30%? Like it is, Let me go back to the previous slide. The examples are simpler there. So 70 if you increment by 30%. So the idea is very simple, right? If you increment 70 by 30%, what are you doing? You're taking the number 70 and you're adding 30% of 70 to it, right? I don't want to calculate 30% because that is not required. So what I did, I introduced a concept. I said if n is incremented by x percent, in this case x is 30, right? Then the new number is 100 plus x percent of itself, of the original number. What is 100 plus x? 130%. So to arrive at the final number, rather than figuring out what is 30% of 70 and then adding it to 70, I simply say that I'll do 130% of 70, right? So rather than adding 30% of 70 to 70, you just do 130% of 70. Okay. And the concept works because every number is 100% of itself.